All right, so today here on campus we did some enrichment on lipids, and so you can download this file from the course website. You can also go, well, not go anywhere. If you don't want to go to the course website, you can just pause this recording, try it for yourself, and then hit resume when you're ready to see the answers. So in the first part, we were classifying each molecule. These are all lipids. We're going to state the family and subfamily if we know it. And then we're also going to state the precursor if we know it, and what role that lipid has in either the body or in nature, something fun fact about it. So here are problems 1 through 3. There's 4 and 5. And then the next questions were just short answer. Classify this molecule as many ways as you can. Precursor molecules, fatty acids differ from unsaturated, LDL and HDL, and then the cell membrane. So now we're going to go over these here on campus, and we're going to talk about the answers. So, number 1, what is this? Close, it's a phosphoglyceride, right? And what family does that come from? All right. Glycerides. What's the precursor? Glycerol. Remember glycerol, you take the backbone here and you unesterify every one of these, you get right. If you unesterify that, that gives you glycerol back. 1, 2, 3, propatriol is the parent molecule. Glycerol. That's why they get their name, glycerides, right? Because they come from this parent molecule, glycerol. Do you remember that? And then for a phosphoglyceride, where would you find it in nature? What's something significant about it? It's got a very important role to us. It's a major component of the what? What'd you come up with? Cell membrane. So remember in the textbook, your textbook represents this as this. That's how your textbook draws it. This is the polar head, right? This is the phosphate. Polar head. And then these are the non-polar tails. Right, that's the cartoon version that your textbook uses. So phosphoglycerides are a major component of the cell membrane. Also a major component of your complex lipids. And the lipoproteins. Do you remember now?
Yes.
All right, let's talk about number 2. All right, what family is this? Now we can actually get pretty specific. Well, we can get a lot more specific than that. We can get more specific than that too. Eicosanoid.
And then prostaglandins.
Right, so it's part of the fatty acid. And then within the fatty acid is part of eicosanoids. And then within the eicosanoids, this is the prostaglandins. And so the precursor for the prostaglandins is very specific. What is it? It's what?
Is it the ring part of it?
No, it's actually arachidonic acid. I wouldn't probably ask you that specific. Arachidonic acid is a fatty acid. It's an unsaturated fatty acid. And what's the role of the prostaglandins? You could have listed a whole bunch. There are a lot of biological processes that are important to us that are regulated by prostaglandins. We specifically talked about one. What is it? Do you remember?
It's a hormone, right?
Not quite. If I smash my finger in the door.
Oh, yeah. So we talked about aspirin.
Inflammation, right. All right, injury. If you have an injury, ouch, right, that gives you swelling. But if you take aspirin, that stops that process from happening. Now, there are a lot of other roles that are regulated by prostaglandins, so I would have accepted a whole bunch of other ones. Regulation of like contractions of smooth tissue, and there's a whole bunch of them. But that was the one we specifically talked about, was the inflammation and injury relationship, and how aspirin inhibits the synthesis of this. We feel good about these two? Like I said, the lipid stuff is just a lot of memorization. It's just a lot of memorizing, which is not something my class is known for, right? I'm not really a class that you do a lot of memorizing in. Okay. What classification is this?
A non-glyceride.
Okay, it is a non-glyceride.
Steroid.
All right, it's a steroid. Specifically, it's a steroid. That's actually the specific structure of progesterone. You wouldn't have to identify that on a test, but just for fun, that's what the specific structure is for that. What is the precursor for the steroids?
Isoprene.
Isoprene, right. Which has what structure? Right? 2-methyl. What's the name of this? 2-methyl 1,3-butadiene, right? That's the IUPAC name. That's this common name. And what's something significant that you put for steroids? They're
Probably for healing.
well, they can be used for a lot of things. Role. I mean, you can talk about bioregulation. You can talk about them as hormones. You can talk about them as cholesterol. CHOLESTEROL. Okay, that didn't look right. Cholesterol is a precursor to most steroids. So other steroids can be made from them, right? You could talk about a lot of different things. Progesterone has a large role to play in pregnancy, especially in your first trimester. But that would have taken a lot of answers here. All right, number 4. What class is this?
Is there a non-glyceride?
No, it is a glyceride. The family there is glycerides. Specifically, this is a 1, 2, 3 triglyceride. So that means that the precursor here is what? Right. Which again, if you just look at the backbone, right, there's glycerol. If you esterify all 3 OHs, that gives you a triglyceride, because there's your ester, right? You've esterified all 3, so that's why I know it's a triglyceride. What are some roles? Do you know of any for triglycerides? A lot of times they're called blood fat. All right. This is a storage form of fat. We have a blood test for triglycerides. A lot of times that's called blood fat, right? It's something that you're looking at concentrations of. I mean, I would have taken a lot of answers. Just like I would have accepted a lot of answers here. You don't want your triglyceride values to be too high, right? Because then that junk can accumulate in your body. I mean, in your veins and arteries and all that good stuff. And number 5. Yeah, that's just a complex lipid. Yeah, I would have accepted complex lipid. I also would have accepted lipoprotein. Okay, there is no precursor. None. And then the role, it varies by the ratio of lipid to protein, right? It's going to vary. This is just a generic one. That's just a generic. I didn't make any specific one there. That's just a generic. So the role here is going to vary by which one it is. Lipid to protein ratio. All right, let's talk about free response kind of questions. Classify this as many ways as possible. What'd you come up with?
Cis unsaturated fatty acid.
Okay, it's definitely unsaturated, right? And let's see. Yes, I would agree that it's in the cis configuration. There's also something else we can call it. Is this omega-3 or omega-6? Remember, we start from the end. Omega means end. 1, 2, 3. That would be an omega-3. Omega-3 fatty acid as well. What precursor molecule is used to make waxes? Small alcohols, right? And just for a review, what role do waxes have primarily? Protection, yep. All right, let's give ourselves more room for number 8 because we're going to need it. How do saturated fatty acids differ from unsaturated fatty acids? There are a lot of differences that we can talk about here.
I put saturated has single bonds.
Okay, so let's just make a column. So these are all CC single bonds versus what in the unsaturated?
At least one double bond.
Right, at least one. Okay, what are some other differences?
Their sub-families are different, aren't they?
Well, I mean, we could, I'm really talking more about physical differences. When you've got single bonds, which one's gonna be more linear? I mean, comparing single bonds to double bonds.
Single bonds.
These are gonna be more linear, right? These are all gonna be linear. Whereas, what will those double bonds put in the chain? The chain has kinks, right? So if we're looking at stackability, which one's more stackable? Oops. Right, these are more stackable. Therefore, these are less stackable. So what does that lead to in terms of intermolecular forces? Who's got stronger London forces? Assuming they're the same chain length. Stronger London forces? Saturated, right? Because these all stack on top of each other. So, therefore, stronger London. And these would be, therefore, weaker London forces. So what does that lead us to conclude here? At room temperature, the saturated fatty acids are usually solid at room temperature. Whereas the unsaturated are usually what? Usually liquids. And in terms of their melting point, which one's going to have the higher melting point? Saturated or unsaturated?
Saturated is going to have the higher.
Right, higher melting point. This one's going to have the lower melting point. Right, so when we're talking about saturated versus unsaturated physical properties, even if the chains are the same length, right, because we wouldn't compare a 20 carbon to a 90 carbon, because that's not a fair comparison, right? If we're comparing chains of similar lengths, there's going to be big differences having double bonds, right? Having double bonds is going to make a big difference. Any other differences you can think of?
Where they come from is different.
Where they come from?
Plants versus
Oh,
animals.
the sources. Yeah, you typically find saturated in usually found in animals, and then the source is what usually here. What's the usual source for unsaturated plants? With the exception of fish, right? Fish oil. Any other differences you thought of? All right. Let's move on to number 9. explain how LDL differs from HDL in as many ways as possible. And we didn't get into as great a detail on a question like this, but we can still talk about some differences. LDL stands for what?
Low density.
Yep, low density lipoprotein versus, what's this one?
High density lipoprotein.
High density. So LDL has a greater proportion, HDL has more, what?
Which one's cholesterol? You talked about.
Well, cholesterol tests are measuring both. When you go to your doctor's office and have a cholesterol test, you're looking at both of these, right? You're not actually measuring the concentration of cholesterol molecule, right? You're looking at how much of your lipoproteins you have are low density versus high density, versus very low and like chylomicron. So in the high density, we have more protein than the LDL does, right? Hence the name high density. And this has less protein than the HDL. Right? If we were sketching this, pain in the neck to draw a little one. There's all our tails. So those are the phospholipids, right? And then let's sketch another one. What's going to be the difference in appearance?
The low density is going to have less integral proteins.
Right, you're going to see a lot less of it, right? So you might have this versus that. That's just a real sad sketch, right? But the proportions are different. And then inside both, you have cholesterol, the molecule, right? The fused ring, remember all steroids have that steroid nucleus. You also have triglycerides inside both. Right, so they're different proportionality of protein makes a big difference. And in terms of the role, right, they're going to have different roles because they have different proportional. But in general, what do both of these have as their general role? Transport of fat, right? All right. So that's really all I was looking for there. But just keep in mind, remember that when you go to the doctor and you have a cholesterol test, your doctor is not saying the molar concentration of the cholesterol molecule is 0.0000 moles per liter, right? That's not what your doctor's looking at. Your doctor's looking at your proportion of LDL, HDL, VLDL, and the chylomicrons as well. And then sketch, everybody's favorite thing to do, mine included. What would it look like if we were sketching the cell membrane? Right, so we represent the phospholipid as these goofy little circles a lot of times. But just keep in mind what that circle actually represents, right? What it actually represents. Got a little bit longer, right? That's really what you're drawing here. You're drawing a phosphoglyceride. This part is the circle, right? And then this part are the sticks. So it looks like in your textbook that, right? This part is polar, this part is nonpolar. So if we're drawing our cell membrane using the notation that most textbooks use, we have these nice little circles. That represents the phosphate group. Then we have our sticks. Is it just one layer? Bilayer. So what's the other layer look like? Is it just this drawn on top of it?
No, it's flipped around.
It's flipped, right? So the nonpolar components all face in towards each other. And if this is a cell, is that all there is to it?
No, there's the protein.
Okay, so there are two types of proteins. What are they?
Peripheral.
What would that one look like?
It's just on the edges.
Okay, so we could draw a peripheral protein like, say, here. What else do we need to draw?
And integral protein.
Integral protein, what would those look like?
So we go through both layers.
Penetrate both ways. We just kind of draw a blob of your choosing. And is that it?
We have cholesterol through all of it too.
Okay, so you can have some things dissolved in here. What about sticking out? Is there anything sticking out?
Yeah.
Yes, if this is the exterior, and this is the interior, just for fun. Right, you could have cholesterol sticking out. You could have some carbohydrates sticking out. Right, your blood typing has to do with this kind of thing. Right, so you can have other identification molecules sticking out. You can also have stuff dissolved here in the middle. So you can just draw some, random shapes. You could even have some things sticking out on the other side too. In terms of transport, right, there are three types of transport that we talked about. There's diffusion, and then there's active and passive facilitation, right? Diffusion just occurs through the membrane. Whereas active transport, passive transport, this is occurring through what? Proteins. And what's the difference between them? Whether or not you're using, right, energy. Going against the gradient versus just moving something that's too big to diffuse. Anything else we would add to our cell membrane? I don't think so. I think that's pretty decent for just a sketch. I wouldn't ask you to go into grave detail. Any questions on any of these?
Yeah, on number 2, is fatty acid the class or the family? Are they the same thing?
On number 2, that would be the family would be fatty acid, but then I want you to give me the subfamily, which would be the eicosanoids, and then technically that would be a subfamily, right? So you would go 3 layers deep on that one. You'd say fatty acid, and then within fatty acid you have eicosanoids. And then within that, it'd be a prostaglandin.
Okay, so like the one before that, the phosphoglyceride, that's the family. And then glyceride is the subfamily?
Backwards. So on this one, the family would be glycerides. And then the subfamily would be phosphoglyceride. Just ask yourself, do all glycerides have a phosphate group? No, right? All phosphoglycerides have a phosphate group, but do all glycerides have a phosphate group? No, right? That's what makes it a special family, the presence of that phosphate group. Does that make sense?
Yeah. So the more specific it gets, the more into the
More layers you have, yeah. Any other questions on this? All right, well, that's where we will stop then.